Hey guys, so today we are going to focus on the kinetic molecular theory. And the theory states that matter is made up of particles that are constantly in motion. That means a solid still has particles that are in motion. They don't move freely, but they vibrate. And we are still on the standard SP81B, which states develop and use models to describe the movement of particles in solids, liquids, gases, and plasma. States when thermal energy is added or removed. Okay, so we're going to move on to some vocabulary. All right, so vocabulary terms for kinetic molecular theory in the video you will be watching are thermal energy, which is energy within a system that is responsible for its temperature. That is just heat energy. Melting point, which is the temperature at which a solid turns into a liquid. Boiling point is the temperature at which the liquid turns into a gas. And then the force of attraction, which is a force that pulls the body near due to its attraction. So before we start this video, there is something that I want to name, and that is that he will call it particle theory. It is the same thing as kinetic molecular theory. All right. He's just going to call it particle theory. Things that you need to look for while watching this video. What happens to the particle bonds when energy is increased or energy is gained? Which states of matter have the strongest force of attraction? Which state of matter has the weakest force of attraction?
In this video, we're going to look at the three states of matter: solid, liquid, and gas, and see how substances can change from one state to another. To do this, we're going to use a model called particle theory, or sometimes kinetic theory, which helps us explain how the particles in each state behave, by considering each of the particles as a small, solid, inelastic sphere. In solids, there are strong forces of attraction between the particles, which holds them all close together in a fixed position to form a regular lattice structure. And because the particles are fixed, the overall substance keeps a definite shape and volume, so can't flow like a liquid. The particles can vibrate around though, so you can imagine them constantly jostling against one another. Now, if we heat up a solid, its particles gain more energy and start to vibrate even more, which weakens the forces between them. And at a certain temperature, which we call the melting point, the particles will have enough energy to break free of their bonds, and so the solid melts into a liquid. In liquids, there are only weak forces of attraction between the particles, so they're free to move around and are arranged pretty randomly. However, the weak forces of attraction do mean that the particles tend to stick together and are fairly compact. This means that they have a definite volume, even though their overall shape can change, allowing them to flow to fit a particular container. If we then heat up our liquid, the particles will again gain more energy, and this will make the particles move around faster, which weakens the forces holding the particles together. Then, once we reach the boiling point, the particles will have enough energy to break the bonds altogether, and so the liquid boils or evaporates into a gas. In gases, the force of attraction between the different particles is very weak, so they're basically free to move around by themselves. This means that gases don't keep a definite shape or volume, and instead will always fill a container as they spread out as much as possible. Now, we normally say that gases are constantly moving with random motion, which is a bit confusing because gas particles actually move in straight lines. They don't randomly swerve. What we really mean by random motion is that the particles can travel in any direction, and they'll end up being deflected by solid walls and other gas particles randomly. When we heat up a gas and the particles get more energy, and so travel faster, the gas will either expand if the container it's in is expandable, like a balloon, or if the container is fixed, then the pressure will just increase. On the other hand, if we cool the gas down enough, then the particles won't have enough energy to overcome those forces of attraction between them, and so bonds will start to form between the particles, condensing the gas into a liquid. As we cool down the liquid even further, the same thing happens. The particles won't have enough energy to overcome the attraction between the molecules. And this time, even more bonds form, fixing the particles in place and freezing the liquid into a solid. Now, the last thing we need to mention is that
all right, so we are done with the video, so we're going to go ahead and go over the review. The melting point is the temperature when a solid turns into a liquid. Boiling point is the temperature when a liquid turns into a gas. Bonds form when heat is being removed. Bonds break when heat is being added. And the kinetic molecular theory states that matter is made up of particles that are constantly in motion. There's going to be a question about which state of matter has the weakest attraction. And the answer is gas. And then which state of matter has the strongest force of attraction? And it's a solid because the particles are tightly packed together. And that's it.